Good morning, Rep 2. How are you? I hope all of you be fine. Today we'll start to study second term, which talk about the motion and the types of it. Firstly, let's remember the meaning of motion. What is a motion? Motion in science is an object's change in position relative to a reference point, or it is the change of position of an object according to the another position, and this is meaning of motion. But there are many types of motion. Okay, from them, first type, translatory motion, and translatory motion like motion of car, motion of train, motion of any moving object on the road. Okay, the second type, circular motion like motion of the earth around the sun, motion of pointer of a clock, okay, or any object moves in circular path. Periodic motion, and this is type is very important to us in this curriculum. Periodic motion means what? It is a motion which repeats itself after a fixed time intervals or in equal intervals of time. Okay, periodic motion are divided into two types. The first type of them that we will study today is called oscillatory motion. It's called oscillatory motion, and the second type is called wave motion like water wave or sound wave. Okay, let's talk about oscillatory motion. And oscillatory motion characterized by the first one, it is a motion of an oscillating body around its rest position or its rest point. So the first character of it, or the first property, this motion around the rest point of a moving object or oscillating object. Okay, the second character type, which regularly repeated in equal intervals of time. Okay, but there is an important relationship between the velocity of an oscillating body and its kinetic energy, and we studied before kinetic energy in Prep 1, and we said the kinetic energy equal half mass by squared velocity. Okay, so the velocity of a moving object, any object, okay, any moving object, affect on the its kinetic energy. So by increasing the velocity of oscillating body, the kinetic energy of this body increase. And we said now the motion of oscillating body is around its rest position. Okay, so this line represents the rest position of oscillating body in this case, and when the object move away from the rest position like this, its velocity will decrease until it reaches zero at a maximum displacement. Okay, but when this ball move or pass through the rest position, the velocity of spring is very high. Okay, or it is the maximum speed at the rest position or at the rest point. So the kinetic energy in rest point is maximum, but kinetic energy in the maximum displacement is zero. Examples of oscillating bodies or oscillatory motion. The first example to us, spring. Second type, swing. Third type, turning forward. And the common type or the common example, pendulum. Okay, but rotary B move in its rest position, not around its rest position. So what about the motion of rotary B? Rotary B is a periodic motion. Rotary B is what? Is considered a periodic motion. Why? Because it's repeated regularly at equal periods of time. But it is oscillatory motion or no? Of course it's not oscillatory motion, because it's not repeated on the two sides of its rest position, but it moves in its rest position. Okay, let's study how can you represent the oscillatory motion graphically. If you bring the spring like this and mass like this and fix it in this mass pencil, okay, and move this pencil or move the roll of paper like this, and the pencil touches the paper and the spring move upward and downward like this, okay, we will find that this shape is formed. Okay, so this shape represents the graphical representation of the oscillatory motion. Okay, and this type or this shape represent simplest form of oscillatory motion, and this form is called simple harmonic motion. And this concept is very important. This shape represents what? Simplest form of oscillatory motion, and the simplest form of oscillatory motion or simplest example of oscillatory motion is called what? Simple harmonic motion. Okay, now let's study the properties or some concepts related to the oscillatory motion. The first concept of them is called amplitude, and as we said in the meaning of oscillatory motion, it is the motion around its rest position. Okay, so when the body move around its rest position, the body make a displacement or maximum displacement away from its rest position. This maximum displacement away from its rest position is called amplitude. So what is meant by amplitude is the maximum displacement by the oscillating body away from its rest point. Okay, so from this figure we can find the amplitude like this: distance between this axis, which represents the rest position or rest point, and the maximum point away from this rest position, which represents the top point or the bottom point. So this distance is amplitude and this distance is amplitude. And as we said, now amplitude represent what? Represent length or represent distance, so its a measuring unit is meter or centimeter. The second concept relative to oscillatory motion, the complete oscillation. What's meant by complete oscillation, and when we can say the oscillating body make one complete oscillation. Complete oscillation is known as the movement made by the oscillating body when it passes a single point in its path of its motion, okay, two successive times in the same direction, okay, in the same direction. And if we represent the complete oscillation of oscillatory motion from the graph, we will calculate the complete oscillation like this. This is, or this axis represents the rest point, as we said. Okay, the path from B to A represents one amplitude, then A to C another amplitude, then C to A third amplitude, then A to B fourth amplitude, and this is called what? Complete oscillation. So we can say one complete oscillation equal what? Equal 4 amplitude. Okay, the last two concepts relative to the oscillatory motion: number 3, the periodic time; number 4, frequency. And we will study all of them together because periodic time is reciprocal the frequency. Periodic time, it is the time taken by an oscillating body to make one complete oscillation. Time taken by oscillating body to make what? One complete oscillation, or 4 amplitudes. So the periodic time equal 4 amplitude time. Okay, but frequency number of complete oscillations made by the oscillating body in 1 second. In 1 second. So if the periodic time increase, the frequency decrease, and vice versa, and we have a mathematical relation between them, so we can find periodic time, which represented by or symbolized by T capital 1 over F capital, which represent frequency, or frequency equal 1 over periodic time. The measuring unit of periodic time second, but the measuring unit of frequency is hertz. Is what? Hertz. Okay, and we have some fractions of hertz. The first fraction, hertz equal 100 hertz, but kilohertz equal what? 1000 hertz, megahertz 1 million hertz, and gigahertz equal 10 power 9 hertz. Okay, now we have finished our lesson today. Thank you for your listening, and goodbye.